This video is an exclusive excerpt from our latest FSW webinar. If you're interested, the complete replay is available for free by following the link in the description. Have a nice viewing!
Hello everybody and welcome to today's webinar. It is our first webinar of the year about cost and friction stir welding. So good morning or good afternoon to everybody. I will let the floor to Valentin Picker. He is our Chief Operating Officer at Stirweld. He has a lot of experience because he's handling all of the prototyping activities, has studied a lot of parts to actually see how long does it take to weld it. So he is the right expert to discuss with you today. Valentin, the floor is yours.
Thank you, Tiffany. Hello, everyone. Let's jump into this presentation. How much will it cost you to weld your parts? Why friction stir welding comparing to other welding techniques? So first part about the friction stir welding process, some basic knowledge about it, and also about Stirweld. Second part will be about comparing the friction stir welding to traditional welding techniques, such as TIG, MIG, electron beam welding, and vacuum brazing. Third part about the economic insights and the comparison, rather from an economical financial point of view, between friction stir welding and the other techniques. And we'll finish in part 4 with the case study of a cold plate friction stir welded. And we'll try to have a perspective on how much would it have cost to weld it with another technique than friction stir welding. Stirweld, we are a friction stir welding solution supplier with our main product, which is this head, this blue box here, which is a friction stir welding head for CNC machine, and which consists in transforming your CNC machine into a friction stir welding machine, adding some functions that are missing on a milling machine to make some good friction stir welds. We are a team of 30 people, and from now we have installed 56 friction stir welding heads like this one all over the world. And regarding the sectors where friction stir welding is already used, we estimate 30% in the automotive sector, 30% in space industry, 30% also in aeronautics, and 10% in defense. Okay, let's have an overview of some friction stir welding existing applications. You can see some cold plates. The one we will make the case study in the end of the presentation is this one on the top left of the screen. You can see also other geometries of cold plates, thinner, thicker, made out of aluminum and copper. We can also weld some extruded parts. We can stiffen panels thanks to lap welds. We can weld some casted parts or some tanks for any storage, gas or liquid. Okay, now let's compare, rather from a technical point of view, the friction stir welding and the traditional welding techniques. Starting with TIG and MIG. The very first differences between friction stir welding and TIG or MIG consist into the feed rate and the thickness that it is able to weld. It's friction stir welding, we can reach a speed up to 4 meters per minute, whereas in TIG or MIG we are limited to 0.2 or 0.5 meter per minute. And also about the thicknesses, by friction stir welding with our Stirweld head on the CNC machine, you can weld up to 10-12 millimeter thick in only one pass. Whereas in TIG or MIG, you're limited to 3 millimeter thickness in one pass. But the main difference between friction stir welding and TIG or MIG rather into the physics of the process, because in friction stir welding, we won't go over the fusion temperature of the material. We will remain under this fusion point. Whereas in TIG or MIG, we have to melt the parts to make the weld. So in friction stir welding, we remain solid into the joint during the weld, and that's why it gives these advantages, the following ones. First, about sealing, we do not have problem with hydrogen avidity of the aluminum when welded. That's why we are 100% waterproof, whereas on TIG or MIG, we might have some porosities that are hard to manage. Regarding the mechanical resistance, friction stir welding often provides twice higher properties if you look at the ultimate tensile strength of the material. The thing is, we are heating less than in TIG or MIG as we remain under the fusion point. So we keep the mechanical properties really close from the one of the base metal. The consumable is also something to be considered as a difference between TIG, MIG, and friction stir welding. There is only one consumable in friction stir welding, which is the tool at the tip of the system, the one that you saw enter into the parts and steering the parts together in the video. This is the only consumable, whereas in TIG or MIG, you have to consider the gas, the filler material, or the electrodes for TIG. Finally, regarding health and security, there is no gas, there is no smoke in friction stir welding thanks to the cold welding process and no electrical risk, as it is not an arc welding process. Now let's have a look at brazing first. So brazing consists in a filler material which will melt, but without melting the edges of the parts to be brazed. It is usually performed into a furnace under inert atmosphere or under vacuum. So from a cost point of view, brazing can sometimes meet the cost efficiency of friction stir welding if we are looking at large batches, but this is only if we look at the direct cost of the brazing process, that are the energy consumption, the consumable, and the time to be spent into the furnace. But if we look at the indirect cost of brazing, and by indirect cost, I mean the non-quality cost, FSW remains most of the time more efficient, as in brazing we can reach a defect rate, a leaking rate, if I take the example of a cold plate application, of up to 30% of the parts to be reworked. Then on electron beam welding, so the how it works, it's in its name. It consists in a beam of electrons that will heat, that will melt the two parts to be welded, and this is also performed under vacuum. So regarding the disadvantages of EB welding compared to friction stir welding, we encounter the same as TIG or MIG, as it is also a fusion process. So we have the same porosities problem and the same heat affected zone and properties weakening process as in TIG or MIG, as we are over the fusion temperature of the material. Then if we look at the gap bridging tolerance, it's almost the same for electron beam welding and brazing, because those two process needs very small gap bridging, very tight gap bridging, as in electron beam welding, the fusion is performed only between the two edges of the parts to be welded, so no gap is allowed. And in brazing, the filler material needs to have a good contact on both parts, which also requires a tight gap bridging. In friction stir welding, we also have a tight gap bridging requirement, but usually a laser cut part is accurate enough, because we do not add any material in the weld neither, but the rotation action of the tool allows to close the initial gap between the two parts. Then regarding the workshop integration, friction stir welding has a huge advantage, and in particular with friction stir welding heads, because they can be plugged directly on the cylinder.
There's still 30 minutes to watch. Access the full video for free by clicking the link in the description below. And don't forget to subscribe to our channel to learn more about friction stir welding.